Hello friends, today we continue chapter 1 of 11th chemistry. We already discussed in previous lecture that what is atomic mass, what is molecular mass. In today's lecture we start with formula mass. So what is formula mass? So some substance like sodium chloride, magnesium chloride and other salt having formula means in that compound there are positive ion and negative ion present, and they are arranged in a three-dimensional structure. You can see here three-dimensional structure in which two color balls are shown. One is positive and another one is negative ion. So many ionic compound like NaCl, Na plus Cl minus, magnesium chloride Mg plus 2 Cl minus, potassium chloride KCl, all are having this type of structure. So in this one sodium or one positive ion are surrounded by 6 negative ion and one negative ion surrounded by 6 positive ion. See here, you can see this, that one positive ion, see this, it is surrounded by total number of 6 negative ion. See the blue, 1, 2, 3 and 4, and 1 and 2 are up, one above and one below. So there are total 6 number of different atoms surrounded. So what happened? So for that type of solid, molecular mass is impossible to count. For that we use formula mass instead of molecular mass. So what is the formula of sodium chloride? It is NaCl. So we add mass of sodium plus mass of chlorine. That is, mass of sodium is 21 and mass of 23 and mass of chlorine is 35.5. So total mass of NaCl is 58.5. So it is formula mass. Here it is 23 for sodium and mass of chlorine is 35.5. So we get 58.5 unit. Now calculate the molecular mass of glucose. It is very easy. How to calculate? So you have to know the formula C6H12O6. So 6, how to calculate? 6 into mass of carbon, because 6 carbon are there, plus 12 into mass of hydrogen, plus 6 into mass of oxygen. 6 into, we get mass of glucose. Now our next topic is mole concept and molecular masses. So what is mole? So mole, you have to just remember that moles means weight upon molecular weight. The equation of moles is, remember, mole is equal to given weight upon molecular weight. Molecular weight of that compound. Now how to calculate 1 mole? In SI system, our fifth number of unit is amount of substance, that is mole. So what is 1 mole? So 1 mole means it contains exactly Avogadro numbers of atoms. Then what is the value of Avogadro number? It is 6.0221476 into 10 10 raised to 23 elements. Okay, if you have a compound having this number of element, then the compound amount is 1 mole. So कैसे हम 1 मोल सब्सटेंस कह सकते हैं? अगर हमने वाटर लिया, सही वाटर लिया और वाटर, वो जो वाटर का अमाउंट है उसमें कैलकुलेट किए हमने कि कितने H2O पार्टिकल्स है, कितने H2O मॉलिक्यूल है. अगर वो H2O हमारे जो वाटर लिया है हमने उसमें 6.022140076 इंटू 10⁻23 मॉलिक्यूल H2O के हैं, तो ही हम कह सकते हैं कि वो जो वाटर है वो कितना मोल होगा? 1 मोल. ओके, वेर एन इसे अगर हमें किसी पार्टिकल का फाइंड करना है कि मोल फाइंड करना है और उसका वेट गिवन वेट दिया हुआ है या मोल्स दिए हुए हैं, तो हम कैसे फाइंड करेंगे? सो हाउ टू फाइंड मोल? सो मोल इज इक्वल टू गिवन वेट अपॉन molecular weight. Remember this equation that mole is equal to given weight. अगर आपको कोई वेट दिया हुआ है और आपको उस कंपाउंड का मोलिकुलर वेट मालूम है तो आप इजीली मोलिकुलर मोल्स फाइंड कर सकते हैं. नाउ व्हाट इज द मोलिकुलर मास और मोलर मास? सो द मास ऑफ 1 मोल ऑफ सब्सटेंस in grams is called molecular mass. For example, molecular mass of water is 18.02 gram per mole, while molecular mass of sodium chloride is 58.5 gram per mole. Okay, now our next is percentage composition. So what is percentage composition? If anyone asks that what is the composition of hydrogen in water, then how many hydrogen atoms are present? First of all, let's start with basic. 2 hydrogen in 1 water molecule. Now, what is the mass composition of water? Then how we calculate the mass of hydrogen in 1 mole water, means 1 H2O, how many hydrogen are present? So how can we calculate? So we get our answer from this slide. So what is the mass of an element? So mass percentage of element is equal to mass of that element in the compound divided by molecular mass of compound into 100. Okay, if you want to find the percentage mass of hydrogen, you have to know the molecular mass of that compound. Here we take water. So what is the molecular mass of water? It is 18 gram. Okay, now what we have to find? Percentage mass of hydrogen. So put the value mass of that element in compound. So in H2O how many hydrogen present? 2. So what is the mass of hydrogen? 1 gram for 1 hydrogen, 2 gram for 2 hydrogen. So I put 2 here. Now 2 into mass of hydrogen 1.008. Now 100 as it is. What is the mass of molecular mass of that compound? So we know what is the mass of water. Here we already know the mass of water is 18.02. Okay, so put this value here 18.02. We get percentage of hydrogen in water, that 11.18% hydrogen are present in 18 gram of water. Now what is the mass of oxygen? The mass of oxygen is equal to weight of oxygen. 1 oxygen is there, weight of oxygen, mass of element in that compound, 16 divided by molecular mass, that is 18 into 100, we get 88.79. Or we can calculate by another method, that we have two components only, okay, hydrogen and oxygen. So if you remove, means subtract 11.18 from 100, I get answer 88.79 easily. Okay, next. Now let's see another example, that molecular formula of ethanol is, we know, C2H5OH. Okay, now calculate the mass percentage of all the compound, that is carbon element, hydrogen and oxygen. Three type of element present in ethanol: carbon, hydrogen and oxygen. So let's start. First, calculate the molecular mass of ethanol. So molecular mass of ethanol, 2 carbon, so 2 into 12.01 plus 5 plus 1 hydrogen, 6 hydrogen, so 6 into 1.008 plus oxygen, 1 oxygen, so for 1 oxygen it is 16, so total is 46.08 gram. Okay, now calculate the mass percentage of carbon. So how we calculate mass percentage of carbon? So mass percentage of carbon is equal to weight of carbon in that molecule. So weight of carbon is 2 into 12, 2 carbons are there, so 24.02 divided by total weight 46.068 into 100, I get 52.14. Same way for hydrogen, how many hydrogen? So 6, so 6 into weight of hydrogen, that is 6.48 divided by total into 100, 13.13. And last for oxygen, 1 oxygen is present, weight of oxygen divided by total weight, we get 34.73%. Okay, so by this we can calculate the mass percentage of each compound. Now there is one numericals are there, empirical formula and molecular formula. Problem 1.2, how to generate empirical formula and molecular formula. So always remember, molecular formula is equal to n into empirical formula. Sorry, molecular formula is equal to n into empirical formula. Okay, so what is n? N is a constant that we derive, okay, for each equation. Let's discuss first, then we discuss. See here, a compound contain 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molecular mass is given 98.96 gram. What are its empirical formula and molecular formula? Okay, so converts this mass percentage into grams first. Okay, so how we convert? So see the above theory, that how we convert gram from percentage. So percentage is given, molecular mass of compound is given. So what I have to do, I want to find mass. So mass is equal to, mass of that element is equal to percentage multiply by the this comes here, molar mass of the compound. So molar mass of compound divided by this comes this 100 comes in a denominator. So we have this type of equation that mass is equal to percentage into molecular mass of compound divided by 100. Okay, so start with this. We get in 100 gram 4.07 gram of hydrogen, 24.27 gram of carbon and 71.65 gram of chlorine is present. So moles of hydrogen is equal to moles. How we find the moles? So divide its weight, means the given weight, you have to divide this given weight by its molecular mass. Okay, so for moles of hydrogen, given mass is 4.07, molecular mass of hydrogen is 1.008, it is 4.04. Molecular mass of carbon we know 12.01 gram. So divide its given weight, 24.27 divided by 12.01, we get 2.021. Now moles of chlorine, given weight is 71.65, molecular weight of chlorine is 35.45, we get 2.021. Okay, now divide each of the value obtained above by smallest number. So smallest number is 2.021. If you divide 2.021 by same, I get 1. If you divide 2.021 by this 2.021, I get 1. And if you divide 4.04 by smallest value, that is 2.021, I get 2. So what I get? Hydrogen 2, carbon 1 and chlorine 1. So I get the ratio hydrogen, chlorine, carbon and chlorine 2, 1, 1. Okay. Now from this I have one formula, that is 1 carbon, it is C, 2 hydrogen, it is H2 and 1 chlorine, Cl. So this one is my empirical formula. Okay. Now how to find molecular formula? So molecular formula is equal to N into empirical formula. Okay. So how to find N? So N is equal to molecular mass upon, means given mass upon empirical mass. Okay, remember this, molecular mass upon empirical mass. So empirical formula, wait, find the empirical. 1 carbon, so 12.01, 2 hydrogen, 2 into 1.008 plus 1 Cl, 35.453, I get 49.48. Okay, so this one is my empirical mass. Okay, now N is equal to molecular mass upon empirical. So 98.96, it is given, 98.96 is given, divided by 49.48. So I get N is equal to 2. So multiply, molecular formula is equal to N into empirical formula. Multiply this empirical formula by 2, we get C2H4Cl2. Okay, this one is our answer. Hope you understand all these things which we discussed in this lecture. The another things we discuss in our next lecture. Thank you.